Welcome to the fascinating world of our celestial neighbor, Sol, the star that lights up our world and powers our planet. Get ready to delve into the mysteries of this incredible body and discover the secrets which lie within its fiery heart. From its origins and composition to the role in the solar system and its eventual fate, we'll take you on a journey through the life and death of this mesmerizing star. So sit back, relax, and let's begin our journey into the heart of Sol. The dazzling orb of Sol has undergone a metamorphosis, expanding and condensing until it reached a state of density and heat that ignited a fusion reaction. It's believed that one or more supernovae may have sparked this reaction, with Sol continuing to fuel it. This theory is further reinforced by the presence of heavier elements, such as gold, within the solar system. Sol is not just a yellow dwarf star, as it emits light of all wavelengths, making it appear white. It is also referred to as a G-type main sequence star, G2V, and is primarily composed of hydrogen and helium, with 73% being hydrogen and 25% being helium. The remaining 2% is a mixture of oxygen, carbon, iron, neon, and nitrogen. You may already know that the Sun is powered by fusion, but do you know the difference between fusion and fission? I'll explain that later. The Sun is the only star in the solar system and boasts an impressive volume of 1.3 million times that of Earth, yet weighs 330,000 times more. It makes up 99.86% of the system's mass, making it the largest and heaviest body in the solar system. To put that into perspective, if you picked a random kilogram, there is a 99.86% chance that it would come from the Sun. It has a diameter of 1.4 million kilometers, or 109 times that of Earth. Fun fact: the word solar comes from the word Sol, the name of our sun. Thank you for taking the time to watch this video so far. Your engagement, whether it is a subscription, like, or comment, is truly appreciated and helps me continue producing high quality content. Your support not only provides encouragement but also demonstrates that there is an interest in this type of content, which inspires me to push forward and create even more. I am truly grateful for your contribution and thank you in advance for your continued support. Anyways, Sol is 150 million kilometers away from Earth, or 1 astronomical unit. It radiates incandescent light as the result of the intense heat generated by fusing 600 million tons, or 600 billion kilograms, of hydrogen into helium every second. This process releases massive amounts of energy, equivalent to turning 4 million tons of matter into energy per second. As the Sun is so large, it takes between 10,000 and 170,000 years for the energy to reach the surface. As the Sun continues to fuse hydrogen into helium, at some point it will no longer be in hydrostatic equilibrium, meaning the gravitational force will be stronger than the force trying to expand the Sun. The core will become denser and the outer layers will expand, engulfing the planets Mercury and Venus and making Earth uninhabitable. Eventually, the Sun will turn into a red giant. But don't worry, this won't happen for another 5 billion years. The denser core will permit helium fusion, but only for a relatively brief period. Then, quickly, the Sun will have no means of creating energy. The Sun will release its outer layers and become a white dwarf, still emitting light from the remaining heat. It will eventually turn into a brown dwarf, a star that doesn't produce any light. As a white dwarf, its density will increase, but its mass will decrease due to the loss of its outer layers. Now, these are just some of the things about the Sun, but there are so many more things to learn, and that is why you need to click on the upper left. We'll explain some very weird things, and some crazy things too, such as the fact that the Sun's magnetic poles switch every 11 years, and the extremely hot atmosphere. It is so hot that it's even hotter than the Sun's surface.